Hey YouTube, thanks for joining me here, and I have an ask for you. I'm looking to get in contact with former employees or a company that owns Rhino Robotics. They used to exist and they built these machines. And if you're a follower of mine, you may have seen many of my videos in the last year. I've been trying to get this working, and controls engineering is not my expertise. So I now have an opportunity with another person and that has those skills to help me get this thing working. And so if we could get drawings for the machines, the electrical schematics, that would be great. It would be so helpful. We'd like to get it working. It's a cool machine. I'm going to give you a tour of it. But this is my ask is, can you get this out into the machinist community here in the US? These things are built in Ohio from like 88 to 1994. And I am sure that there was paper prints because they were designing this thing in the 80s. So maybe there's a cabinet somewhere in a basement that has like a file tray with blueprints. Would love to get this thing working. So I'm going to show you what I got. I also have some manuals and training material for it that I'll show you as well. So stay tuned. This is a 7-inch swing lathe, and it has an 8-position tool changer here as well. It uses pneumatics. That presses down and then it shifts, and then there's a lock right here. This locks the carousel, I guess you call it. And then this opens up, and then this goes up, and then as it strokes down again, it rotates another 1/8 of a turn, and then this lock comes in. So there's 2 air cylinders in here, and right now it has these Humphrey micro valves. They're not available anymore. I talked to the company, they still exist. It's great that a lot of the stuff that they built this machine from, these companies are still in business today. So I think they went with high quality commercial components on the design of this. It's got DC servo motors. Those have encoders on them. They're full-blown servo motors, 48-volt drive. My buddy that does the controls engineering told me that's should be a really nice high-powered drive. So great bones on this machine. I am replacing this with 2 of these because this is not, these are not available anymore. So I have 2 of these to replace 1 of these. Simple low cost parts, no big deal. So that's the tool changer. That's what's really cool about this, is that it has a tool changer. Now I will plug this thing in and we'll turn it on, and you can see that too. Let's take a walk around the back side of the machine. So the cover is off of the back of the lathe, and there's the drives for the X and Z, and then I think this one here is for the spindle. Here's the spindle motor. It's a DC. It's a Leeson motor, DC. There's the 48-volt power supply and the big capacitors. Those have been de-energized, in case you're wondering. But these are custom drives by Rhino Robotics. That's why I know they got drawings. In fact, I'm going to zoom in here for you on this. So if you look right there, it says right on that circuit board, Rhino Robotics, Champaign, Illinois, and there's a phone number even, 217-352-8485. And then it looks like part numbers there. And then let me see if I can turn the camera here. This is the drive for the X and Z. Let me zoom in here. You can see it says lathe amplifier 48 volts version 2.0. So I know there's drawings out there. There's also the serial cables here. Let me set the camera down. Another thing that we have here is the communication between the top and the bottom. So look at all these pins. You know, we don't have the pinout on this. No idea what any of this stuff does. I know there's a schematic out there. Here's the upper control cabinet. It has 3/4 turn screws. And voila. There's our CRT. There's the keyboard. I'll zoom in on this stuff too so you can see more of it. And then of course on the outside over here, we'll just take you over there. Is the startup computer. So this is what we're gonna look at next. You know, all of this stuff is physical switches, modeled after the Fanuc 6T controller. It says in the manual exactly. But you know, all these custom boards. Look at that. 1988 Rhino Robotics, Champaign, Illinois. This is the 90th one they built. This machine was finished in 1992, is what it appears to me. But look, they got a part number for this board. So yeah, baby, I know we have drawings. Like, this is just crazy. You know, and here we have the PC. It's a 486 Intel processor. You can see it down there at the bottom, and I don't know, I think that's RAM. Room for more RAM. You could probably go buy that RAM for 50 cents and put it in there. And there's the disk drives. And then also on the back side of this is all I/O for integrating with robots. That was part of their thing, was an educational machine on how to integrate with robots. So there's all of the I/O on the back of this. And I have the cabinet sitting on top of the lathe, but if I started running this lathe much, I don't think I'd want to put the vibration on the cabinet. So the way you get this shut, these things are a little tricky. These 1/4 turn screws, you got to get them lined up just right, and then it goes in. And so I'm still trying to get it. I got one of them is always stuck. You know, this just seems like a very strange way to do this, but I guess it does close pretty nice. So for manuals, I've got multiple manuals, and they have a date of their creation and revision and everything. So here's one of them, and it goes all the way back here. It has this has a lot of interesting information in it, the way they explain how they built the machine and the intent behind it. Now here's actual 3-ring binder, hard-sided. Here's another. This is an earlier manual from 1989, the ST8. And then also there's actually 2 manuals. Here there's this one also. It says version 1.01.21 from 1991. And so somebody crossed out the 6 and put a 7 up there. This is a ST7 lathe. So there's, multiple operator manuals. There's not a parts diagram. There's no drawing. That's what I'm looking for your help with. But there's also introduction to G-code programming and on a lathe. You know, my plan was to learn the Fanuc control with this and be able to hand G-code. And it gives you, look at this, it has exercises. Incremental programming exercise. Programming angular motions, tooling and plunge cuts. Programming 90-degree arcs, programming partial arcs. Tool offsets and tool changes. While there are a few texts written about CNC for the educational environment, none approach the subject specifically for the Fanuc type controller. They are largely more generic and as such have their strong and weak points. Okay. So they do recommend referencing now is a Computer Numerical Controls Simplified book written by Mike Fitzpatrick and published by Glencoe Publishing Company. Maybe I should check that out. So it has lessons on what you can do. So I think it's really valuable that this stuff still exists with the machine. So now we're going to go to the next thing. All right, now we're going to power up the machine. It's 120 volts. So I got it plugged in. The disc here, this is the operating system right here. And this is right there. There's no 5 1/4 floppy in there. You press the button. And then it starts to turn on. I will move. So I'm gonna see if I can zoom in on this. So here we are with the machine on. Now there's a couple errors. CMOS RAM checksum. And then there's some warnings here too. Unexpected amount of memory found, run setup, math coprocessor hardware information incorrect, run setup, floppy hardware information is incorrect, run setup. I don't know what to do about those things. I can press F2 to run setup. But I'm just going to continue so you can see that this thing does actually come to life. So the position button seems to be what is F1, and now it's going to run the program that's on the disk. It's just taking its sweet time. This isn't starting MS-DOS. Can you see that on the screen? Yeah, you got a good view of that. All right. Here it comes. Imagine trying to troubleshoot all this stuff without having drawings. There we go. All kinds of information right there. That's the website and everything. Yeah. Yep, you can see that plain as day. In fact, I'll even pull this up here real briefly for a second so you can see it real easy. Yep, okay, so we're still loading here, but I'm letting you see the whole thing. Maybe I can adjust this down a little bit more. Okay. There we go. Oh man, it's so slow. System loading. Okay, there we go. Boom. You can hear the servo motor right now. And so this is the position page. There's a UW, X, Z, or both of them along with machine coordinates. So now if we're in edit, the positions on the operation, mode of operation where this is red means I can jog the servos. You can see that there. It says pulsar. Here, let me just back this up a little bit and zoom out a little bit. Let's see here. Okay. So now I have it set to X, and oh, you're not going to be able to see this, so I gotta zoom out even further here. Let's see, what can we do here? Okay, there we go. Right there. So I got it set to X, and now I just turn the pulser. It's going up and down very slowly because I have it at 25% feed rate. 50%, I'm not noticing much of a difference there, but oh, there we go, handle 100. See, there it is. That was at, it was at 100, I think it was at handle 10, maybe that's 10 steps per revolution, and so now it's faster. Here's rapid is disabled for some reason, but okay, so there it's going up and down. This is the x-axis, and then the z-axis is the other direction. There we go. So that's operating as it should. I love it. These servos make noise, they hum, it's fun. You move them, it stops humming. So I'm able to get to all this stuff. Let me get back to a view of the screen now. And maybe I'll zoom in a little bit more again. Yeah. Okay. Sorry folks, like to keep you watching here. So you got here's the program button that shows you where you're at in the program. Here's an offset button for your tools on your tool changer. Command button, I don't know what this is. A set button, not sure what this is. Parameters on the machine. Again, it'd be great to have drawings to make out this information. There's an alarm screen. If you get messages here, you try to clear the condition and then you hit the reset button. I don't have any alarms right now. There's a diagnostic screen that shows you all the different bits of the machine. So if I move a switch, I can see the handle changing, which this one appears to be right there in line 3. Again, all this stuff obviously with drawings would be great. So and then you can, this is the jog handle for homing. So that's a lowdown of the machine. This machine would be great educational value. So I'm really hoping to get some help with locating the people that used to work for this place. I hope you enjoyed the little run through of the Rhino lathe here, and I hope you can help me be a part of saving this machine. Thanks, have a nice day.